Hello, let's introduce our innovation to you. It is in the field of air freight for goods that aims to increase its speed and efficiency while reducing costs by delivering goods in more than one airport during one flight of the carrier plane by dropping the goods from the air accurately, tightly and safely in special containers without the need for the plane to land the supplies. The dropped container will be using highly accurate guidance systems taken from military technologies used to drop precision bombs in surgical bombing during military operations. Now we'll see overview. It is just like that. The airplane dropped a container. It is guided by GPS and INS guiding systems, sending information to the wing assembly that guides the container in the air. And in the last phase of the dropping process, laser target designator will guide the container into a specific spot inside the drop zone. And now we are going to see how it does work, the whole system. It does work in this simulation. This is the first stage, detecting the drop zone. Now the pilot got alarm, audio-visual alarm on the head-up display, and also that he reached the airport, the airport that should drop the shipment into the drop zone in its area. So we'll take the decision to drop the shipment, and after that we're going to, as you see, the plane will not have to reduce its altitude. It will be continuing its flight on its altitude, which is in the normal flights will be 11,000 meters. And now the role of the navigation systems will start after opening the air carrier door. And here is GPS and INS systems. It is inside the container here. Also sending the information to the wings assembly here to guide the container in the air. Like that. And here is the third stage of the dropping process, that laser target designator will determine a specific spot here for the container, specific empty spot inside the drop zone, because to be away from any other occupied spots with other dropped containers. And here is the laser receiver for the signal, the laser signal, and it is here accurately dropped. Now we'll talk about some problems that face the air freight, and after that we'll see how it does work. The first problem is the time. Sometimes we face delaying in delivery of the air freight, of the shipments, and this is because of the recent planning system of the delivery for the shipments and also the flights. Because it depends on the available flights, the available planes, according to the destinations, the type of the shipment itself, so many factors that really affect directly on the air freight process and the planning. So they use the recent system in planning the air freight and the delivery system of the goods. It is called pipeline. Let's talk about it. For example, in Cairo airport, it has several shipments, and each shipment is going to a different destination. So each destination will need different plane, different flight, and different time. So this will use process of many processes of taking off and landing of the planes, different planes, and that will take much more time. If there is nothing or no available flight to any destination, that would lead lead to delaying the delivery of the shipment. So, and the second problem is the cost. All of us know that the air freight way in shipping of the goods takes costs high. This is really due to the fuel consumption at takeoff, which is related to the large number of flights needed to transport cargo to different places and consumes about one-tenth of aircraft's fuel during just one takeoff. The maintenance of the landing system in the aircrafts during the frequent takeoff and landing, which leads to rapid damage, and also the maintenance in the runways in the airports during to also frequent takeoff and landing. The third problem is unreached destinations, the islands, countries that lie around mountains, remote countries that don't have any airports, and places that don't have many flights to reach. So these countries will suffer from the delaying in delivering any type of shipments. So you will have to use some other ways like sea shipping, or maybe using mules to deliver goods in the mountain areas. So our solution will solve these problems. So we design a special container ULD according to these specifications. Its width from the bottom is 1.5 meter, and from the top is just 1 meter, and its height is 2 meters, and it is designed like this just to prevent the container during the dropping from dropping on its side or maybe upside down in the dropping process. And also it is with wings used to guide the container in the air and inside the drop zone, specific drop zone that is taking information from the guiding systems GPS and INS, and it is used like this. This is the recent container, this is our container, and we provided it with 2 or 3 parachutes that can carry its weight with the goods inside. And these are the systems taking. This is our container, and it has INS system inside, GPS system, laser receiver in the container bottom, and all of that is taken from the JDAM bombs, as you see, and the laser guidance in the drop zone to guide the container into a specific spot in the drop zone. And now these are the devices of the GPS and INS in the bombs taken from JDAM bombs, the details of INS and GPS systems here like that. And these are according to the specifications of guiding systems used in the JDAM bombs, and that will be used in our ULD and our container. That can the highest flight altitude of the civil aircraft will be 12,500 meters, and the highest height that allows the guiding systems and the dropped JDAM bombs will be 13,700 meters, and with more 1,000 meters difference. And also the range of the dropped JDAM bombs, the range will be about 24 kilometers. So we'll have a great chance for the shipment to be really dropped inside the drop zone. So these are the components that are used in the dropping process. This is in the first stage, the head-up display system, and here is the V platform inside the carrying the cargo planes. It is like that moves the airdrops inside the plane after dropping cargo towards the door. And here is the CG system that modify the distribution of the weight inside the plane in the payload space. And here is the guiding systems. And here is the drop zone. For example, it is about 2,500 square meters, that it is divided into spaces that receive containers, and also some roads between the containers that allow the trucks that go inside the drop zone and take the containers to unload the shipments from the containers. And it has also a mapping cam that really guides the laser target designator like this. If it is the blue dots here, that means it is the drop zone, it is empty at all. And if it is occupied, it will be marked with the red spots. So the laser target designator will guide the dropped container into any of the empty blue dots. And this is the guidance laser designator that it is used with the special forces from the land to guide the bombs dropped from the bombers. So it is this the equipment. And for the safety of the goods, we are using these special equipments. 2 of G11 parachutes, that each one of them can carry 2,270 kilograms while the container, so maybe both of them will can carry more than 5,000 kilograms, while our container will, the total gross weight may be 2,070 kilograms. The honeycomb will be inside the containers. It is used to protect the drop from damage after hitting the ground. Okay, and each until it can carry 30.7 tons per square meter. It is designed like that. And here are our advantages of our solution. The current solution in planning the delivery, the delivered shipments, the pipeline can take off 5 times. For example, here 5 times, and landing 5 landings. Plane lifetime will be less. Delivery time will be high. The price of fuel in takeoff just one in 5 times 100,000 and $120,000. Using, of course, the model of the plane is LM100J. It is produced by Lockheed Martin, and in our solution, just one takeoff can reach 5 different destinations. One takeoff, one landing. Plane lifetime will be more. The delivery time will be lower than pipeline system. The price of fuel is just one takeoff and one landing is $24,000. So the advantages, the planning system of the delivered shipments will be changed from pipeline to one-way, saving time and fuel cost. Unreachable destinations. It allows making accurate dropping from high altitudes, even in the lack of visibility. We can reduce the number of required flights to transport cargo, reducing the cost of aircraft maintenance. Here are the difference between pipeline system. It is if the distance between two spots will be just 8,000 kilometers, and the flying path will be 10,000 kilometers. In our system, if it will be just 7,000 kilometers, like this. The project cost, of course, according to the components of the recent system and our system. Airdrop parts will be like this. The equipments in the airdrop itself, and here are the equipments of the in the drop zone in the airports, and this is the difference between them. Here's like that. And here is our resources. And thank you.